Hello, boys. Good morning. Every day we start our day with a new morning. Fresh morning just reminds us that we have to start our journey with a refreshment, with new rhythm. And all of your students, all of your Gregorians, and as a Gregorian, you have some oath you have to keep in mind in that oath, and you have to work so that you can achieve your goal, you can achieve your dream, you can work for humanity, you can work for your family and for the society. Everything will be achieved if your desire, if your trying is the if you just try your level best, then everything will be achieved by you. Boys, we were just trying to review our whole syllabus, and we were just focusing on the creative type questions from different chapters, from important chapters. And on our last class, we just discussed about the chapter current electricity, and today I will try to discuss a creative question from the chapter magnetic effects of current, that means chapter 12. Let's start the class, and let's follow the stem first. Here the stem is 1 horsepower electric motor is connected by secondary coil of a step down transformer. Number of turns for primary and secondary of the transformer is 250 respectively. The voltage and current for the primary are 800 volt and 2 ampere respectively. Boys, whenever you are given a question in exam, or in whenever you are just practicing in house, first of all, just read the stem very carefully. Read the stem for several times so that all the points get clear to you, and you just can make a solution for that if you just review the stem again and again, and you will be able to realize the question, and that will be easier for you to solve the math. So what are the questions according to this stem? In this stem we have got the idea about transformer, number of turns for the transformer, the primary voltage and current for this transformer is also given, and the secondary winding of this transformer is connected to a electric motor that operates with power of 1 horsepower. And then we have to determine, first question is, what is electromagnetic induction? Number B, why does resistance increase in resistor but decrease in semiconductor with increase of temperature? Number C, determine the resistance of the primary coil. And number D, whether it is capable to run the electric motor by the transformer that mentioned in the stem. Your first question is, what is electromagnetic induction? You are familiar to the process of induction, the phenomena to produce electric current, electro and magnetic. That means electric and magnetic properties are involved here. The phenomena to produce electric current in a closed circuit by variable magnetic field is called electromagnetic induction. That means the process of generating current or electricity by the changing magnetic field is called electromagnetic induction. Why does resistance increase in resistor? Question number B, why does resistance increase in resistor but decrease in semiconductor with increase of temperature? Resistance, in terms of resistance, there are, as we know, in every particle has some free electrons, but in resistor the free electrons, number of free electrons are much more than the semiconductor. So what happens over here, as the resistor has more free electrons, whenever the temperature is raised, then these free electrons gets extra energy and try to move first, and that's why they gets collide, and these collision just increases the resistance. But in case of semiconductor, number of free electrons are less than the resistor, so whenever temperature is raised, these free electrons moves, and movement of electron just raises the rate of electricity. As we know, the due to the movement of electron, the electricity is generated. So in case of semiconductor, when the temperature is raised, the movement of the free electrons is also raised, and that's why electricity is generated over here, and that means the resistivity or resistance is decreased here. As we know, whenever there is increase in electricity, that means there is decrease in resistance. So these are the reasons why does resistance increase in resistor but decrease in semiconductor with increase of temperature. Now let's see the question number C. Determine the resistance of the primary coil. We have to determine the resistance of the primary coil. For the primary winding of the transformer, the primary voltage is 800 volt and primary current is also given 2 ampere. So as we know from Ohm's law, for the primary winding we can write Vp equals Ip Rp, then Rp equals we'll just get the result over here, 400 ohm. We have to determine the primary the resistance for the primary winding, and this is our result, that is 400 ohms. Next question number D. What is our question number D? What is our question number D? The question number D is whether it is capable to run the motor by using the transformer as the motor is directly connected to the secondary winding of the transformer. That means the voltage generated by the transformer will run the motor. So is it capable for the transformer to run this motor or not? This is our question. So for that we have to determine the current that is required to run the motor, and at the same time we will also have to determine the current generated by the secondary winding. If both the current matches, both the currents gets equal, then we can say that the motor will be run by the transformer. So first of all we have to determine the current generated by the current that is required for the motor. Current required for the motor, that will be I equals P divided by V, that means power divided by voltage. As we know, P equals VI, this equation. So power divided by voltage, the power of the motor is given 746 1 horsepower, that means 746 watt, 746 watt. And what will be the voltage over here? To measure that voltage we have to measure the second voltage for the secondary windings first. And as we know, voltage and number of turns and voltage are directly proportional in case of transformer. So for that we can write Vp by Vs equals Np by Ns, where Vp is the primary voltage, Np primary number of turns for primary, that is given 200. Number of turns for the secondary is 50, and primary voltage is 800 volt. Then we can determine the voltage for the secondary will be 200 volt, and this voltage will operate the motor. So using this volt, the current that will be generated, that will be required for the motor, that is I equals P by V, and we get the current over here is 3.73 amps. So we have got the current required to run the motor, but what amount of current the secondary windings generates over here? To calculate that, we have to use the equation P equals VI. As we know P equals VI, we can write it like that: IP equals VS IS, where IS is equals VP IP divided by VS. That means here the current is inversely proportional to voltage, so we can measure the current over here. That will be 8 ampere. This current is the current generated by the secondary winding, that is 8 ampere. But in our earlier calculation we have got that the current required to run the motor is 3.73 ampere, but the transformer provides a current of 8 ampere. So using this transformer, we can say that using this transformer, this is possible to run the motor, because the required current for the motor is less than the generated current by the transformer. So it is possible to run the motor using this transformer. Actually, in this chapter, that means magnetic effects of current, in this chapter mainly transformer based questions come to your exam. If you just follow the question from different board, from different board, if you just follow the different types of board question of this chapter, you will see that most of the questions are related to transformer. And the best example for magnetic effect of current is this transformer, where induction process, electromagnetic induction process is used, and using this step up and step down transformer are formed. Some questions related to step up and step down transformer, where the step up transformer are used, where the step down transformer are used. And if you are given a question about a transformer, and if you are asked whether it is usable for household work or industrial work, if that kind of question come to your exam, you can easily answer that by calculating the range or calculating the output of that transformer. And if that one matches with the required voltage for household use or for the industrial use, according to that you can make a comment. And I think this chapter is important, but this is a very easy chapter for you to make a good preparation from this chapter, as there is not so many variety of questions over here. There are not so many equations in this chapter. So if you just try a little bit, you will have a good preparation on this chapter. So boys, we are trying to just focus on some specific questions only, but it is your work to practice all kind of questions. And you have to find out your limitation, you have to find out your problems, and if you just need our help, you can share it with us. We will try our best to help you. And just try to work hard, try to work more. And definitely, if you just utilize your time, you just work hard, it is must that you will get a good result. That's all for now, boys. Take care of your family, and make support with your institution, with your family, and pray for all. That's all for now. Goodbye.